Okay. My name is Z Chen. I graduated from Princeton with a PhD in mechanical aerospace engineering, and I've worked as an assistant professor at Dartmouth and Harvard Med School. And it's my great pleasure to share with you some of the mathematical tricks that will help you excel in math competitions such as AMC 8. So let's start with Jordan and onwards, okay?
Hi.
Mm,
Um, so should I just introduce myself?
yeah, yeah.
Hi, my name is Jordan. I'm homeschooled. Uh,
Mm,
yeah, I'm in eighth grade, basically.
mhm. And your hobby?
Oh, hobby. Oh, uh, I guess I like to play with Legos.
Okay, cool. And I like singing and brain games like chess and Go. And math, of course. All right. Thank you, Jordan. Next. If you could open up your camera, that would help us know you better and have better interactions. Kinza.
My name is Genzer, and I'm in fifth grade, and my hobby is playing soccer and video games.
Okay, great. And other people? Joan, hey there. Is this not showing the screen? I'm very confused about what the screen is showing. Wait, which screen are you seeing? Let me close up this. Other people, could you briefly introduce yourself? Okay, maybe you are just shy. All right, let me reshare the screen anyways. Oh, slideshow. Oh, is this what I'm supposed to be showing? Yeah, I'm a bit confused about the configuration. Because what you're seeing is, let me remove the slideshow maybe. Because what I'm seeing here is not so today we're going to um do some geometry problems, and I have the title, how to solve AMC 8 type of geometry problems beautifully. Um for some reason this is not the screen, so I have a projection here, but the screen projected is not what you're seeing. So I need to get rid of that. Okay. And then I need to restart sharing. Sorry about the inconvenience. Oh, any other person who would like to briefly introduce yourself while we're resharing it? Jeff, are you there?
Hi,
Mm-hmm.
my name is Jeff. I
Mm-hmm.
am in fifth grade and I like playing soccer.
Okay, great. Okay. In the interest of time, let's just get started. I assume you can all see my screen now. So today we're going to go through some geometry problems. So first, let's start have a brief overview. So I assume that most of you know for geometry shape, right? So we can have, parameter, which is the sum of the total side length, right? And area, and then length. for rectangles, we have width, height, um, and for, sort of circle, we have circumference, radius, and the side lengths and polygons. Now, the basic formula, so parameter is just you sum up all those three numbers, right? A plus B plus C. Now, for the area of a triangle, it's 1/2 base times height, right? And now the question is for an equilateral triangle, how do you find the area?
Base times height over 2.
Okay. So can anyone show that this is the answer? Like if we know the base is A, right, for an equilateral triangle, basically all three sides are A, how do you show the total area? How do you find the total area? Oh, full screen. Yes, I'm trying to do full screen, but for some reason it's not letting me click on it. You don't know? Like, oh, maybe here. There's a slideshow, maybe I should go to. And where's the full screen? From current. Let's do that. Wait, is it showing? Can you see my full screen now, or because I'm not seeing it? Could you see the full screen now? Uh, are you seeing the full screen right now?
No, I can only see one screen. Like I can only see one slide.
Okay. Is this better? Oh, who's drawing it? Is this better now? Can you see
No one
this
was.
It's
page?
better, but we can see like the other
Oh,
other
you can
one.
see the next. Okay. Um, is there a way I can
I think you should try one of those buttons down there. Yeah.
here? Wait, which one? See all slides. Black, black or unblack? Wait. Uh, this one, this one. All right. Let's just go with this. How about that? All right. So so the question is, if we have three sides, right? Um, we know three sides are all A. How do you find the area? Now, in the interest of time, I assume a lot of you would know. So we can draw a line perpendicular to the base, right? So we know that this is A, and because this is perpendicular and this is isosceles, right? So the two sides are equal. So each one, wait, you're not seeing it. Wait, why are you not seeing? I'm confused. Yeah, you can see it over here. So this is 1/2 A, and that is 1/2 A, right? And then within this right triangle, we can apply the Pythagorean theorem. So the height square plus A over 2 square is equal to A squared. And that will give us H squared is equal to A squared minus A squared over 4, right? So it's 3 over 4 A squared. So H is equal to square root of that, 3 over 4 A squared. And that is square root of 3 divided by 2 times A. Can you see that? Because square root of 4 is 2.
What does square root do?
Oh, square root is basically finding the number whose square is equal to it. For example, we know 2 square equals 4, right? then if we apply the square root, right? So square root of 4 is just 2. That makes sense? So
Yeah.
square root of 4 means this number, when you square it, you get 4. So that's like the inverse of the square. Now we have solved for h, right? Is square root of 3 over 2 times 8. Now we can use this equation. So a is equal to 1/2 times the base is a, and the height is square root of 3 divided by 2 times a, right? So that would give us square root of 3 divided by 4 times a squared, right? Because we have a times a. Okay, so this is an answer, is a result that you know, if you can memorize this, it would be very helpful. But if you don't remember it, you can always derive it using the Pythagorean theorem. That makes sense? So in mathematics, it helps for you to remember where things come from. So even if you don't remember this result, which I highly recommend that you memorize it. But if you don't, then you can still derive it very quickly using the Pythagorean theorem. And in triangles, right? Anything involve triangles, um, Pythagorean theorem is very powerful. Okay, so it helps us to get quantity relationships. Now, this formula is universal, so A equals 1/2 B times H. Now, if let's say the triangle goes like this, then it's the same. So you can still draw a line perpendicular to the base, except that, it's outside. But that's okay. But still, the area is still base times height divided by 2. Okay? And that also tell us if I have a parallel line here, right? This line is parallel to the bottom. And so if I draw another triangle which share the same base, right?
Well, the formula is the same.
Yeah, so the formula is the same. So base times height divided by 2. That now because these two lines are parallel, so the height here would be the same height here. So the heights are the same. So the total area should be the same. Okay. So as long as they are sandwiched between these two parallel lines, then, and they share the same base, then the area is the same. And this is often very useful in solving AMC or other, higher level geometry problems. Okay. Now, for a right triangle, of course, that's simple, right? Because height is just one of the legs. Now, there's also a very useful Heron's formula for calculating the area. So that is when we know all the three side lengths. So if we know the three side lengths is A, B, and C, and doesn't matter whether it's right triangle or not, it can be any triangles. Then first we calculate 1/2 of the parameter. So S is 1/2 of A plus B plus C. Okay. And once we calculate have the half parameter, and we can put it in this formula. So this formula is S times S minus A times S minus B times S minus C. And then you take the square root. Okay. In the future, I can also teach you how to prove this. But for now, let's just say if you can memorize this can be helpful at times. Okay. Help you simplify the calculations. Now I have a question. So because when we take a square root, we want to make sure the product is, what's the restriction for the product within the square root? Can anyone tell me what we need to be careful about within the square root sign? This whole thing should be
Solved.
positive. or at least 0, right?
Yeah.
Because square root of a negative thing, what is square root of negative thing? Well, in the future we'll learn, but in this course, I mean, in pre-algebra, let's say it doesn't exist, right? Um, because okay, so think about what square root means. Square root means if this is equals x, so when we do, so it means -2 equals x squared. That's the meaning of square root, right? So x is the square root of -2. That means x squared equals -2. But we know if x is a real number, then x squared should be greater than or equal to 0, right? It can never be negative. So that's why, so in this course, we say that, this is not defined, okay? Does not exist. And therefore, for this formula, we want to make sure this product is positive, okay? Then it can mean an area, right? Now, how do we make sure this is positive? Well, if we look at what this formula is, I may have to raise something. Let me see if I can erase. Wait, I can erase these, right? You've all seen it. So my question right now is, how do we know, can we make sure that S minus A is positive? And likewise, S minus B, S minus C, they're all positive?
Yeah.
How do you know it's positive? Okay, so let's take a look at S minus A. Okay, so S is 1/2. So it's A plus B plus C divided by 2 is S minus A, right? So to do this subtraction, what we can do is to say this is A plus B plus C, and then minus, so here we think of A as 2A divided by 2, right? So that they have the same denominator. Now this becomes minus 2A. That make sense, Nicholas? So we basically rewrite A as 2A minus divided by 2. Right? 2A divided by 2 is still A. Now they have the same denominator, then we can put the common denominator here. And then we say, A plus B plus C minus 2A. Now this becomes B plus C minus A divided by 2. You see that? So in any triangle, we know that any two sides length adds up is greater than the third side length, right? And therefore, B plus C minus A is always positive. So that divided by 2 is always positive. Does that make sense?
Yeah.
So likewise, you can also show S minus B, S minus C, they're all positive. So we have no worries when we calculate, square root of this. S minus A, S minus B, S minus C. Okay? Because each of them will be positive. Okay? Make sense? And in general, if you have any questions in this class, feel free to raise hand or just unmute yourself and say, "Excuse me, I have a question." Okay? We don't want the questions to accumulate. And okay, so let's take a look at an example. Okay. So in this example, we know, I'll let you read it. We know the area of ABC, and we're gonna find out the shaded area. You need a pen? Okay. Yeah. Yeah. So area is 1/2 base times height. So how do you find the area of the shaded triangle? Okay, and type your answer in the chat or privately to me, okay, when you finish it, so I would know your progress. And then when a few students have the answer, then, we can go through the problem together. Okay, I've seen some attempts. What do you think?
I'm not sure how to solve it.
Okay, that's fine. Mhm. Some of the answers are poorly designed. Like A, you should probably immediately abandon. Right. Okay. So I think you've attempted it, and let's go through this together. Okay, how do we solve this time problem? There are actually multiple ways to do it. So one way is to say, okay, so we know that the area is base times height, right? And so the question is which base we use, which height we use, right? And also we have to make use of the known conditions. So for example, we know the total area ABC is 16. Now, ABC is 16 is pretty straightforward. So let's say this side is A, right? And this is H, right? So we know, so basically, how do you translate the problem description into equations, right? So 16 is equal to 1 half times A times H. You agree? That you understand, right? 1 half base times height. Now, and we want to find out the shaded area. Now, what is the shaded area? DEF is equal to 1 half. Now, which base we use? Maybe we should use this base, right? So 1 half DE times, well, the length of DE times this, right? So this is H times the lowercase h. Now, what's the relationship between DE and A or H and H, right? So we know we have to use other conditions. So DE are midpoints of AB. So D is the midpoint of AB. So that means AD equals DB. And then E is the midpoint of AC. So AE equals EC, right? So what does that tell us? Um, so that tells us the this is 1 half of AB, right? So, or in other words, AD over AB equals 1 half, right? And AE over AC is also 1 half, right?
Yeah.
So in triangles, um, this is pretty useful is if we have two triangles like this, let's say this triangle ADE, if we compare AD and ABC, right? So they share the same angle A, right?
Yeah.
And then in terms of the length, it's 1 over 2, right? And it's 1 over 2. So that means these two triangles are
Uh,
similar to each other, right? Do you understand the idea of similar triangle? So you can think of it as this is a shrinked version of ABC.
yeah.
We shrink it by half,
Yeah.
right? Or ABC is the, expanded version of that is twice. So that means all the corresponding lengths would be twice, right? So in other words, the height of ADE would be 1 half of the height of ABC. That makes sense? And so the height of, ADE would essentially be the same height as FDE. Can you see that?
Yeah. So so
Because
it's C.
yeah, so that means okay, so H is equal to 1 half times bigger large H, and DE is 1 half of BC. This is 1 half of A. Okay, so now if we rewrite DEF, so it's 1 half times 1 half A, 1 half H. So this is 1 over 8 AH. So we already know 1 half AH equals 16. So what is 1/8 of AH? If you compare these two, so it's just 1/4 of 16. You see that? So that is 4. Okay. Okay. Does that make sense to you? So this is one way of doing it, following the definition of um the definition of I mean the following the standard formula for calculating the area of a triangle. And then we take use of take advantage of the fact that these two triangles are similar. Okay. Have you learned about the similar triangles? How many of you have learned about similar triangles in the past? Okay. So similar triangles, um, so we basically this triangle is ADE is similar to ABC. So you can think of ABC as just scaled, right? Proportionally scaled, doubled in all the length. Um, okay. Are there any questions? Now, if you have not learned similar triangles, you can also do it. So let's see how you could have done it without using the concept of similar triangles. So in this, the second way to do it, okay, is if we pick the midpoint of BC, let's say it's G, right? So you connect G and D, um, and then G and E, okay? Now, because DE and A and BC, they're parallel. They're parallel because D and E are both midpoints of the two sides, right? So these two are parallel to each other. And then we previously said that, if we look at the shaded area versus um, like DEG, right? These two triangles, they share the same base, DE, and their height is the same. You see that?
Yeah.
So they have the same base, same height, so they have the same area. Okay? And now, if they have the same area, then we just need to look for the area of DEG instead. Make sense? So how do we find the DEG area? Well, if we look at DEG versus ADE, they are
Similar. The
they're
same.
not only similar, they're congruent, right? They're essentially the same, just differently oriented. Can you see that? Because they share the same base here, right? And you would find out that this side is actually the same as that side. So they're parallel. These two are parallel, and these two are parallel. So they're parallel again. So when you connect, the diagonal line, these two are congruent. All the sides corresponding, like this side equals that side, this side equals that side, and one side coincide. So the area is completely the same. Now, what about this one? BG, uh, BDG. So BDG and DEG, they're also congruent. You can see that?
Yeah.
Same idea. And here, EGC is also congruent to that. So we basically have four congruent triangles and they have the same areas. So 4 times the area equals 16. So S is unknown is equal to 16 divided by 4. Okay? So that's another way you can find the area. And of course, some people, I mean, if you couldn't come up with this, some people were just eyeballing. So that's why I said the result, I mean, the it's pretty eerily designed is that you can immediately throw out this and probably throw out that as well. And maybe even throw out that because this is 1/2, right? And this area is not nearly 1/2. Um, So the only viable choices would be 4 and 3. And as you probably noticed that we haven't even used this condition. So sometimes they will give you like, redundant or not needed information. So you have to have your judgment. Okay. Not all the conditions need to be used. Okay, any questions, comments, or do you have a better method, an alternative method? I always encourage people to think about, alternative ways to solve the same problem. And that's a very healthy practice, very helpful. Once different ways to solve the same problem, that just broaden your perspectives and in the future, hopefully, you can come up with quickly the best way to solve a problem. Okay, we're good. All right, let's look at the next problem. Oh, this is too easy for you. Points. This is like a 5-second question. Yeah, you got it. So how do you quickly translate the description into expressions? You got it.
Uh,
Okay, other people got it. Okay, so this is just right triangle, two legs. One is so you just basically apply the base times height divided by 2. So you can do this mentally, right? Okay, good. Let's move on to okay. Okay, you got it. Okay. So if you have already solved it, look at this question. So I have why am I not drawing it straight today? So a square inside a square, and let's say, let me see. Okay, let's say we have a point inside here, and that divides the square into a few areas. So let's say we have a point here, and we connect, I'm sorry, we connect the midpoint, okay, with this. So the midpoint of each side. Um, okay. And we know this is, let's say this 30, this 34, and this 38. And what is this area? Okay. So we know that this is midpoint. So this is midpoint, midpoint, midpoint. And we know the three of the areas we would want to find out the fourth. So if you finished example 3, work on this problem, okay? And please type your answer in the chat. And for this problem, I'm going to give you a few choices. So this problem, I'm going to give you 26, 28, um, 30, 32, and 34, okay? You understand the question? So we have a square, okay? And then we, you know, have all the midpoints on each side. And then we choose a point inside. Let's say this is A, B, C, D, okay? And then we have E, F, G, H. And then we pick a point O and connect O with E, F, G, H. And so that partition the full area into 4 polygons. Now we know the area of 3. We want to find out the fourth. Okay. Mm. Uh, Double check your answer, okay? Make sure the logic is correct.
Wait, me?
Yeah.
Oh,
Yeah, make sure you're not just guessing around. You have to have a base. Okay. I assume example 3 should be very simple. So type your answer in the chat, okay? So this would be our bonus example. Mm-hmm. Yeah. Oh, can you see that? I'm sorry. I don't know today why it's not showing up. So this, we have a square, and then all these are midpoints. And then we connect a point inside with the midpoints. So we know 3 of the areas. We want to find out the fourth. Yeah, so for example 3, a lot of you have found out because, I mean, that's pretty straightforward. So BC equals DC. So if you look at this area versus that area, so they share the same height, right? The height is the same. and the base is, same length, so they have the same area. And so if one of them is 8 and the other is 8, then total is 16. So that's pretty straightforward. Now, for this bonus question, how do you find out? And you can use pretty much the same trick, right? If the two, you know, triangles have the same base length and same height, then they have the same area. Okay. So basically you need to take advantage, know how to take advantage of the conditions given. Oh, Jeff, what does that mean? You're thrilled? Challenge accepted? Yeah, this one's a bit challenging. Oh, hey, Bobby. Sorry, I didn't notice that you were disconnected. Okay. Did you see the problem? Do you understand the problem? We're working on the bonus problem, and so we start with a square ABCD, and E, F, G, H are the midpoints on each side. And then we pick a point in the middle somewhere, and that's O. So connect O with E, F, G, H so that, those four line segments partition the square into four areas, and we know three of them. How do we find out the fourth? Okay, yeah, that's fine. Yeah, this program is designed to foster a creative problem solving. So you will encounter some, challenging problem, but I think that's good for you, is to, learn how to apply the concepts learned and then, come up with creative solutions. And in geometry, oftentimes, drawing some auxiliary lines help. Okay. So that's kind of the what the difficulty is, you have to make use some hidden information, right? Yeah, that's why some people think geometry is among the most difficult part of AMC. Um, and plus the counting probability, perhaps. Okay, anyone has any these? How do I draw a straight line? Right. CT GH. Nicholas, do you have any thoughts?
No.
Mm-hmm. We actually have seen this before. You remember?
Okay.
Yeah, that's okay. Yeah, it's. Oh, but I need to project it so you can see it. What do you want to come to this to my side so you can actually see it? Mhm. I apologize. I don't know what happened today. Continue. Okay, shall we look at it together? Okay. Does anyone have any thoughts to share? Kingsley, you want to say something?
Well, I have no idea, honestly.
Okay. But you have an educated guess? Or is it by eyeballing?
Well, I'm not eyeballing it. Like, I'm thinking like the other side is 34, so it might be 34 on that side. And there's 30 on the corner and 30 on the corner, and it's in between those two numbers.
Uh-huh.
And 38 plus 30 equals 34 plus 34. So I was
Okay.
thinking it might be 34.
Okay. That's a good guess. Okay, let's look at this problem together, okay? So because we have, H is the midpoint, right? And likewise, F is the midpoint. So what happens if we connect OB and OC? So these are the auxiliary lines. I mean, just like in the previous problem, like this problem, everyone can do it. No, right? It's straightforward. But it's this very, very similar, right? Because we have F is the midpoint of BC. And when we connect OB and OC, so that's exactly this, right? So we know that this area is equal to that, correct? And similarly, if we connect OD and look at these two sides, I mean, DG equals GC. So that means this area and that area is the same. Can you see that?
Yeah.
And if you connect AO, right? So then this area and that area is the same. Yeah. And then, so basically, let's say this is X, right? And this is Y, and this is Z, and this is, T and T. Okay. So now we know that y plus z is 34, and z plus t is 30, and x plus y is 38. And the question is, what is x plus t? See, now we translate the problem description into mathematical equations, right? So this is the skill I hope you can master, is that how do we translate the problem description, word problem, or geometry relationship into mathematical equations? And don't be afraid of naming variables, okay? You can name variables and it typically just means that we need the more variables we have, we need more equations. Okay. Now, how do we solve for x and t? Well, if you observe it, so x is here and t is here. So naturally you would say, okay, how about we just add up these, right? If we add them up, we have x plus t and plus y plus z. And on the right-hand side, you have 68. Now, x and t is what we want, right? When you add up these two, so you get x plus t plus y plus z, right? Is equal to 38 plus 30. Now, this is exactly what we wanted. And this is what we don't want, but that's okay because we know y plus z is 34. So this is 34. So x plus t is just 68 minus 34. So x plus t is 68 minus 34 is 34. Okay? So E. Make sense? Yeah, this is one of the questions that if you solve it, you'll be very satisfied. Okay, because it's kind of challenging, but it's solvable using the knowledge that we have already learned. Does that make sense to everyone now? Does anyone not understand this problem yet? Ha, are you there? Is that your name? Har.
I have no idea.
Oh, show. Yeah. Do you understand this problem now? Show.
Yeah, kind of.
Oh, kind of. Okay. Um, and what about Jeff? You got it?
Yeah.
Okay. Now, um, we actually can solve this the same problem using another method. Okay. I kind of want to show you. Um, so let me erase this. So I always love to have multiple solutions for the same problem. Okay, so for this problem, okay, so actually from here, you can also say, okay, so when we add these up, right, we have x, y, z, t added together. And when we add these two, we also have x, y, z, t, so they are equal. So basically, you know, diagonally, when you add them up, it's the same as these two diagonal pairs. Okay, that's how we can solve it. Um, and you can see that from these four equations. Now, another way to see this, to see that the diagonal regions add up to the same, is to say, is to consider the following. Okay, so let's say this, that, this, and that. Okay. Now, what if we connect this, that? So connect all the midpoints. So we draw the auxiliary lines by connecting all the midpoints. Now, when we do this, so we notice that this is just a isosceles right triangle, right? And this is also the isosceles right triangle. So they are congruent. They have the same area. And same thing here. It's all the same deal, right? So all these four are isosceles right triangles that have same area. Now, what's the difference between this and that? Is just this area, right? So basically, um, now we basically want to show, this area plus this area equals the sum of these two areas, right? And what other sign? This is question mark, right? Um, Now you can see this pretty quickly actually, because if we want to calculate this area, what you do is you take this base times the height here. So height is when you draw a line, starting from O, you draw a perpendicular line here. That's the height. Now, to calculate this area, you draw from O, draw another perpendicular line, right? So when we calculate the total area of this versus and that, what you do is you do 1/2 times the base. Now this base, what is it? If this is A, this is A, what is this side?
8 times 8 divided by 2.
8. Well, it's A squared plus A squared divided by, I mean, Pythagorean theorem, right? So this side square equals A squared plus A squared. So this hypotenuse square equals 2A squared. So it's basically square root of 2A squared, right? That's the hypotenuse. And it's also the base of this. So we have 1/2 base times this height. Let's say this is H1 and this is H2. So times H1 is this triangle. And then for the other triangle, it's the same base, right? It's the same base, and then plus H2, right? And what is H1 plus H2? Well, H1 plus H2 is basically just this length. You see that? And this length is also the hypotenuse of this triangle. So it's also square root of 2A squared. You see that?
Yeah.
So that means these two add up to the same to this number. So you can calculate it as 1/2 times 2A squared. And that's just A squared. Right? So these two add up to A squared. And likewise, you can show that these two also add up to A squared. Right? So they have the base times height and base times height. You can see that? So that's why, these four triangles, they add up the diagonal ones add up to the same. Now, if we go back to the original, so now can you see why 38 plus 30 is equal to 34 plus the unknown area? Because this is the same, right? So all these four are the same. So if we know this area plus that equals this plus that, then adding the same components wouldn't change that balance. Can you see that? So that's why 38 plus 30 is equal to 34 plus the unknown area. So the unknown area should be 34. Does that make sense? Does that make sense to everyone now? So we draw additional auxiliary lines and use the area equation for triangles to show that the diagonal regions add up to the same number.
It makes sense now, yeah.
Okay, good. And other people, please do give me some response. I know that you are here, you're listening, you're understanding, right? Rona, are you there?
Yes.
Oh, okay. Do you understand it now?
Yeah.
Okay. Um, and other Ha, are you here? And Bobby?
Yes.
Okay.
Okay.
Do you understand the two solutions to the same problem now? Okay. I hope it's
I
enlightening.
do.
Okay, great. Okay. And Joan, Jeff? Yeah. Okay. Show. Great. Yeah. Stevenson. Okay. All right. Let's move on to the next problem. Let me erase these. Um, I think this is too easy, so I'll just skip it. Okay, this one. Find the area of a triangle with the sweet side angle. And if you want to take a, bathroom break or, water break, feel free to do so, okay? Yeah, we can take a couple minutes break. And if you don't need a break, you can continue to think about this problem. It's not that difficult, I hope. But who knows?
I was working on example 5. Oh yeah, it's 294.
Okay, some people worked out. You know how to, like, what's your approach? Oh, no. Oh. So we have three sides being 21, 28, and 35. How do we find the area? So if you already solved the problem, think about if you have any other method, okay? You can always do better. So doing better could be calculate faster or finding a better solution. Or sometimes even if it's not a better solution, we can find an additional way to solve it. That's also a great achievement. Okay. 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 Could you tell us how you solve this problem? Are you there? Can you unmute yourself and tell us how you solve it?
Wait, me?
Yeah, ha.
Me?
Yeah, ha who?
Wait, me. Sure. Did you ask me?
I was asking ha who.
Oh,
Yeah, there's a student HH. Are you there? I saw that you just typed the answer. Could you show us how you do it?
I can tell you how I do it.
Okay, okay, go ahead then.
So I did 28 times 21.
Mm-hmm.
And then I divided that by 2 because that's half of of like the rectangle, so that equals 294.
Okay. But how do you know it's 21 times 28?
Because that will form the rectangle. That will be equal to the rectangle. And that triangle is half of the rectangle. Nah, but you
But
don't know if it's a right
how do you know it's the right triangle?
triangle or not. You could do the Pythagorean theorem and then do it. Ah,
Yeah,
dang it.
yeah. Okay. Was that King, sir?
You have to do the
Oh,
Pythagorean theorem first.
yeah, exactly. We want to make sure that it is the right
Oh, and I
triangle.
didn't notice it was 21, 28, and 35 are all right. It's all like it's all
Yeah,
the 3, 4, 5 right triangle. It's all part of that.
exactly, exactly.
And I
That's
didn't
right.
notice, so I did the formula you taught us like earlier.
Uh-huh.
How like you add all those up and
Oh
divide
yeah,
it by and divide by 2, which is 42, and then I did
yeah.
42 multiplied
Okay,
by
good.
42 minus 21 and then that's how I got
That
294, right?
that's great. Yeah, that's great. Um, so you mentioned quite a few methods already. So, like, one of them is to say, if 21 plus 28, like page C, what I'm writing, is equal to 35 square, then it's a right triangle. You're not seeing what I'm writing. Um, Wait, are you seeing what I'm writing? But how do you verify 28 plus 21 square plus 28 square is equal to 35 square? Well, what I would recommend is that you do, wait, why are you not seeing what I'm writing? The screen sharing is pretty weird. So I don't know why it's not showing. Previously it was showing. Let me switch to this. Oh, now it's coming up. It's just delayed. Huh, that's significant delay. Now, to verify the Pythagorean theorem, you can actually use the famous a squared minus b squared equation. Do you all know the a squared minus b squared equation? What is a squared minus b squared equal to?
A plus B squared.
No. Well, but you have something correct. So it's a plus b times a minus b. Why is this delay so much? Let me switch to this traditional way. So you know that, yeah, this is much faster. A squared minus b. Oh, now it's coming up. Oh, okay, maybe I can keep with it. So, usually, I mean, in order to calculate 21 squared plus 28, that's a lot of calculation, right? But if we verify 35 square minus 28 square, that's a quicker calculation because now we can do 35 plus 28 times 35 minus 28, right? So 35 plus 28, it's 64. And 35 minus 28 is, um, wait, is for 35 minus 21 is 14. Oh, minus 28, sorry. 28 is, um, 35 minus 28 is 7, right? So you have, 63 times 7, okay? So 63 times 7, and 63 is 7 times 9. So we have 7 squared times 3 squared, and that is equal to 21 squared. I apologize, there's delay, but I hope you hear me. So basically what I'm saying is that it's easier to check 35 minus 28 squared, and you can use this and show that it is equal to 21 squared. Now that it's a right triangle, you can do this. So 21 times 28 divided by 2, okay? So that's E. And another quicker method is, as Kinsler pointed out, because they all have this common factor 7, right? So if we divide that by 7, it's just 3, 4, 5. So it's the famous 3, 4, 5 right triangle. So that way it's quicker. So you can find out immediately it's a right triangle. And then the area is just 21 times 28 divided by 2. Okay. And if you don't um know all of these, you could also just use the previous equation. So calculate what is S first. And S is 1/2 of, A plus B plus C, and you use the square root of that. Now it just comes up. Everything I wrote like 1 minute ago. Okay. Does that make sense? So that I think that's what the solution does is, I don't know, my computer is doing something weird today. So you can use the Heron's formula. Square root of S times S minus A times X minus B times S minus C. Okay, that's kind of a no-brainer way of solving the problem. Okay. That's this. I may erase everything here. Oh, I know why. Do you hear me well right now? Because I feel like whenever I switch to this mode, people online are not hearing me very well.
Your voice is like glitching out.
Okay. So I think it's because when I share the screen in that mode. So if I just share the regular mode, do you hear me
It's
better?
better now. It's better now.
Yeah, because when I do the full screen mode, it tends to like use AI and it's fancy stuff, but then I noticed that my voice quality decreases significantly. Um, so we have to find an alternative, I mean, compromise somehow. Um, but yeah, so here we are. Let me see. Okay, so this is the Heron's formula, right? So you calculate the parameter, half of the parameter is S, and then you just do this. I mean, it's no-brainer way. Or, if you find out that right triangle, then you do that way. Okay. Um, so for rectangles or parallelogram, so the parameter is just, 2 times length plus width, and the area is, length times width or height. Okay. Um, and so, and okay, so this is also very useful. So in the parallelogram, ABCD, if T is any interior area, then when we connect T with ABCD, then the um so TAB, right? This area plus this area. So the two areas touching on at one point, they always add up to 1/2. Okay. So remember in the previous problem, right? In the previous challenging problem, we kind of use this, right? So in this problem, so when we connect this with the midpoint here, with the midpoint, with the midpoint, with the midpoint, right? And we said that if we draw these 4 lines connecting the midpoint, so this is not only a parallelogram, but it's also a square, okay? So in this square, these two diagonal areas, right? I mean, these two, opposite positioned areas, they add up to 1/2 of the total. Okay. So that means the other two also add up to 1/2. So they're the same. Can you see that? We already used this idea. So, so here, what I'm saying is that this triangle plus that triangle is equal to 1/2 of the total area of the parallelogram. And you can see that by considering the formula. So this is the base, right? And the top is also, AB is also the base. So when you calculate the sum of these two, so you do 1/2 base B times the height. So height 1, height 2, they add up the total height. You see that? And then divide by 2. And that's why the area, these two sum up to the 1/2 of the parallelogram. Okay, so this is a very useful conclusion. Okay, now let's do another problem. So for a rectangle area of a rectangle of 4 cut areas, okay? So if we have all these 4 cut areas, then you can find out what the other area is. And how do you do that? So this is this is an AMC 12 question. Okay. So a large rectangle is partitioned into 4 rectangles Let me erase this. And so we know the three of the areas. We want to find out the fourth. Okay. So how do we find out the area of the fourth rectangle? And why? B, because I'm smart. Okay. All right. And if you find out how to do it, think about, do you have any other method? Right. If you come up with another way to solve the same problem.
I think I know how you did it.
Oh, cool. How?
Uh,
Wait, is it 15? Because this side could be 2, this side could be 3. Since this side is 2, then this side is 7. This side has to be 5. So this
Yeah.
side is 3 and this side is
Okay.
5. So this is 15.
Okay. Yeah, that's a good way to do it. And you're lucky because they can be decomposed, right? So you can say 2 times 3, and then this could
Yeah.
be 2 times
In
7.
AMC, in
Huh?
AMC, um, in AMC, like, you could just try something out, and if it works, you don't have to
Yeah.
check again. Like
Yeah.
if it works, that's the answer. They don't have
Yeah.
multiple.
Yeah. Yeah. That's right. That's right. Very good. Um, Now, what if, we cannot easily find the factorization? Because this problem, they kind of giving us a break and allow us to find the easy factorizations, right? So what if they cannot be factorized easily?
uh,
Like for example, if I have the same problem, but I have different numbers. Let's say I know this is, 5 and this is, 12 and this is, you know, I don't know, uh 60. Oh, what is that? Right?
uh,
So in this case,
what
2 times, like what is it?
equals 5?
Oh, okay. Oh. And then,
Uh, and then 2.5 is on the longer side, so then you do 2.5 times 6, I don't know, because 6 and 10, most likely.
so how do we come up with a systematic approach, right? In the event that it cannot be easily factorized. Or sometimes the answer could be like fractional, right?
Um, and then 15, nope.
Can you find this answer, this area? How many of you have taken AMC 8? It was probably this past week, right? Oh, Kinzer did. Oh, did you do it in middle school? Oh, where did you do it?
Oh,
Like, where did you take it?
I don't know.
I took it at school,
Oh, okay. Dwight?
um, upper school
Oh,
in
upper
AMC.
Oh, okay. Oh, oh, RSM. Okay. Wait, which RSM? Jeff, where are you located? Mm-hmm. Okay, so how do we solve this? Do you still see my share screen? You still see my share screen, right? Okay. All right, let's look at this problem together, okay? So, here, one way to think about it is to say, okay, what if this is A and this is B, right? If we label this is A, this is B, and then this is H1. Can you see my screen? And this is H2, right? I mean, you can do the same thing here, on the original. So you can say this is A, this is B, and then H1 and H2, the two types. Now, if we look at these two areas, so 14 is equal to, well, if we consider a ratio, like 14 over 35, right? 14 over 35, they have the same base, right? So it's B times H1 divided by B times H2. Can you see that? So if we calculate 14 over 35, Nicholas, you understand that?
Yeah.
So B would cancel each other. So 14 over 35, the area ratio is just the height ratio, right? Now, if we consider 6 over x, right? 6 over x is A times H1 divided by A times H2 because they share the same base, right? A. So the ratio is also H1 over H2. So they are equal to each other. You see that? So now we have basically 14 over 35 is equal to 6 over x. And they have the same common factor of 7, so 2 over 5. So you do cross multiplication, right? So 2 times x is equal to 5 times 6. So x is 30 divided by 2, so 15. Okay. So in geometry, this is very useful. So is to look at the area ratio, okay? Especially if the two geometry, the shapes, they have the same side or, they share the, same base, for example, then the area ratio is just equal to height ratio. Okay. Does that make sense? So using this method, then we don't have to guess around. Like even if you cannot factorize it, like for example, here, you can just say 12 divided by 16 is equal to 5 divided by x, right? So 12 over 16 is basically 1 over 5, right? Is equal to 5 over x. So x is just 25. Quick and easy, right? Yeah. So I hope that is inspirational to you. Any questions? And for the same problem, there are different ways to solve it. So, um, you know, this, so I kind of quickly go through this slide. So this relationship, now you understand it, where it comes from. So if the, the area of rectangle with four cut areas, right? So it's A, B, C, D, then A times C is equal to B times D. Make sense now? Okay, very good. Now, for the rest of the time, I'm going to show you um, a quick um, question, okay? So this, do you understand Chinese? Like,
No, no.
oh no, okay. So basically we have a right triangle here, and we know that uh there's two segments. So this segment is okay, is 2, and then the other segment is um the other is 10. Okay. So we know 2 and 10. And we want to find out this shaded area. Okay. So, now people all believe AI is very powerful. So, Gemini 3 Pro is like one of the best AIs. And so I try to, use it to see, how well it does. And okay, so I put it in there, and it does recognize this as Chinese. So it start to respond in Chinese, saying, 好的，这是一个求阴影部分的面积. So okay, this is a looking for the shaded area geometry problem, and then blah 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 blah. Here's the steps. What we know, 2 and 10, and there's a right the rectangle. One angle is located in the right triangle. Um, so blah blah blah, and okay, and then something interesting happened. Um, so it says, wait, this is incorrect. Then I switched to English. Let's look at the small non-shaded triangle at the top. 它的高手. So it's like it's mixing English and Chinese now. Uh, and then it says correct, blah blah blah. And then it says, oh, let's re-examine the diagram. Okay. Rethink the diagram interpretation, blah blah blah. And then it kind of and then switched to Chinese again, for some reason. So I think it somehow get confused. I don't know. Um, and then at the end of the day, after, 3 lengthy pages, it arrives at this conclusion. Well, it says rethinking is the shaded area rectangle. But anyway, so at the end it says, therefore, the simple intended answer is likely the area of the largest inscribed rectangle. And the final answer is 10. Okay. And then switch to Chinese again. Now, is this correct? I mean, this is like presumably the best AI, right? And so I also asked ChatGPT, okay? But anyway, so ChatGPT started using like some analytical geometry, which is fancy. But anyway, so how do we solve this type of problem? And I can tell you that the answer is actually not correct. So the Gemini 3 didn't get the right answer. Okay. So how do we solve a problem like this? Um, Wait, I think we went a little over time. I apologize, but just got overly excited. You guys are holding on very well. Um, but yeah, I mean, we can take this as a take-home problem, and then you can think about it. How about that? So just a hint that you can use the regular um the equation for uh the right for triangle, and then see what you get. Okay. But my point is that, even the best AI sometimes can make mistakes. And that's why you shouldn't, trust AI too much. And I think ChatGPT also didn't give the right answer as well. So they both failed. And see if you can do better than AI in this problem, okay? Do you want me to solve this now, or I mean, you want to do it at take home? Either way, it works for me.
I want to solve it myself, honestly. I have a really boring weekend.
Okay, okay. So yeah, we take it as a take home, and thank you very much for attention. And we do have, if your parents are interested in signing up for our class, you can add WeChat here, the lower right corner. So this is a graph that is divided into four areas. Now you know the relationship between the four areas. Okay, so we're the lower right corner area. So contact me so you can, we can continue this next week. Okay. All right. It's great to have you and hope to see you again. And we have a pretty systematic training for AMC. So this is a geometry part. We also will work on the permutation, the counting, permutation, combination, probability, those difficult parts, and logic, reasoning, and algebra. Yeah, word problems. You name it. Okay. All right. I hope you enjoyed it. And also, feel free to let your parents know about your feedback. Let me know the feedback so we can always adapt and cater to your needs. Okay. If it's too easy, too difficult, or appropriate, or things you like me to, talk about in the future, I always welcome suggestions. Okay. All right. Great. So if you have any questions, you can ask me here. Otherwise, have a great weekend, and I have to see you again next week. If in case this time slot doesn't work for you, you can also add your parents contact me, okay? We'll see if something can be arranged. All right. Any questions, comments from anyone? All right. Have a wonderful weekend. And yeah, once you sign up, we'll also assign the homework
All right.
and
Bye.
set up the Google Classroom for you. Yeah. Right. Bye.
Bye.
Bye, everyone. Okay. Stop sharing.